Good evening. This is Professor David J. De Los Reyes. It's January 11. The time is almost 2:19 a.m. Good morning to everybody. My topic for tonight is about advanced mathematics, and this is now lesson number 3. Okay, let's continue, guys. This is a new topic. Advanced Mathematics lesson number 3. Okay, example number 2. Example number 2. Because lesson number 1 is actually the concepts on how to solve a higher order non-homogeneous differential equation. And the lesson number 2 is a first example on how to evaluate a second order non-homogeneous differential equation. So as you notice it, lesson number lesson number 2, the past one, and number 3 are both second order non-homogeneous differential equation. Maybe the next topics will be a third order derivative, maybe, because I have already given you 2 examples on the second derivative non-homogeneous. Okay, let's proceed. I will check my camera. Oh, it's fine. So this is now advanced mathematics lesson number 3. This will be example number 2. The given non-homogeneous second order differential equation is this. Y double prime plus 4y equal to 3e to the 2x. Find the general solution. It should be the total general solution. Total. Why total? Total because there are 2 parts of the solutions. It is referred to as the, what do you call this? Where's the... Because the total general solution is actually equal to the sum of the complementary plus the particular. And this is termed to as the total. Total refers to the sum of yc plus yp, complementary and particular. Okay, let's try to bring out the solution. Solution, we shall start with the complementary solution. Okay, same as the last topic on differential equation. For the complementary, the substitution will be this. Y sub c will be equal to k e raised to mx. As always, it's always like this, right? If we take the derivative of y sub c will be km e to the mx. We will take again the derivative of the first derivative. What comes out is y double prime c, meaning the second derivative of the complementary solution, equal to km squared e to the mx. There is an m over here because the differential of the exponent is actually m times 1. M times 1 is m times k, that will be km. For the y double prime, it's a km squared because we will multiply km by m again. So what comes out will be a km squared e raised to mx. Okay? Substituting and equating to 0. Okay? That's why I will underline this one, substituting and equating to 0. Meaning, we will take the value of y sub c and y double prime. We'll place back here. Okay? Then we equate it to 0. Equating to 0. That's the procedure on how to take the complementary solution. Actually, the given differential equation, the right-hand side is not 0, but for the solution of the complementary, at the time of taking the solution, we equate the right-hand side to be 0. Okay? So what comes out will be km squared e to the mx plus 4k e raised to mx, and this should be equal to 0. For the simplification of this, to eliminate the common terms, we multiply all the terms by k e to the mx, right? So this one here and this one cancel with the one at the bottom. What remains on the first one will be an m square. For the second part, this k here cancel with this e to the mx cancel with this. So what remains will be plus 4. For the right hand side, 0 times 1 over k e to the mx is still 0. So what comes out for the characteristic equation is actually an m square plus 4, and this should be equal to 0. And we are now given a quadratic characteristic equation. To solve for the solution complementary, we must have to solve for the possible roots of n. Okay? M square will be equal to negative 4, that is after the transposition. Okay? M now will be equal to, if we try to take the square root of both sides, these two here cancel with this, right? So what remains on the left will be n equal to right hand side. It will just be simply the square root of negative 4, because negative 1 times 2 square is negative 4. The one inside is negative 4, right? Okay, but don't be afraid with the negative sign inside, because actually we could take the square root of a number that involves a negative sign. Under advanced mathematics, that's possible, okay? So we will replace that negative 1 by j square. Or sometimes they replace this negative 1, j square is negative 1. This should be negative 1. Or we'll just use j square. We'll replace this negative 1 to be equivalent to j square. So what comes out will be the square root of j square and 2 square. J is a perfect square, 2 is a perfect square. Okay, we could take the square root. Since we could take the square root, it could either be plus or minus. The square root of j will be j, or j square rather, will be j, and the square root of 2 square is actually 2. So m now will be equal to plus or minus j2. Or actually, we could write the m as something like this. The first part is 0, right? So we could either write it as 0 plus or minus j2. Okay? And by using the positive sign, the first root will be 0 plus j2. Using the negative sign, the second root of m will be 0 minus j2. And actually, under this falls under case number 3. Okay? Case number 3. Case number 3. In which the resulting roots are actually complex numbers. Complex. Complex meaning we got a real part and we got the imaginary part. The real part is alpha and the imaginary part is beta. Real part is 0, imaginary part is actually 2. So for the complementary solution, this will be e raised to 0 times x, or this is this 0 here is actually alpha x. Okay? Alpha x. But if we now try to substitute the value of the computed value of alpha, alpha is actually 0. So I place this as 0. Okay? E raised to 0 times x times the quantity k1 cosine of 2x plus k2 sine of 2x. This is beta. Okay? This 2 here is beta. Okay? 0 times x is 0, e to the 0 is 1, so actually it seems this is 1. So what comes out now, if this is 1, we could remove that 1, it's understood to be 1, right? Therefore, the complementary solution now will be k1 cosine of 2x plus k2 sine of 2x. That's the part of the complementary solution. It is a complex expansion. Okay, let's try to bring out the particular solution. For the particular solution, okay, this is the hard part, because you will base your particular solution on the given right hand side. And if you try to inspect the right hand side, it is an exponential function, right? It is with coefficient 3 times the exponential function e to the 2x. So supposed to be the particular solution will be a certain constant a times e to the 2x. And for the meantime, we do not know the value of a. This is a. Y sub p. If y sub p is equal to a times e raised to the 2x, take the first derivative, y prime of the particular solution should be equal to 2a times e to the 2x. Okay? This 2a emanates from, because the derivative of e to the 2x is actually e to the x times the derivative of the exponent, and the derivative of the exponent is actually 2 times 1. 2 times 1 is 2 times a, so this is 2a. Okay? Taking the second derivative, y double prime of the particular solution should be equal to, it is the same. 2a is constant. Okay? We multiply that again by 2 upon reaching the second derivative. So 2a times 2 will be 4a times e to the 2x. Okay? Substituting. You take the value y double prime to be 4a times e to the 2x plus, I am following this, plus the product of 4 times the value y. But what is y? Y for the meantime is referred to as y, right? This is a times e to the 2x equal to 3e to the 2x. These are similar terms. This is e to the 2x, this is e to the 2x. The coefficient of the first one is 4a. The coefficient of the second one after the multiplication is also 4a. So 4a plus 4a will be 8a. Okay? Times e to the 2x, and this should be equal to 3e to the 2x. Okay? So we now have formulated an equation. Okay? That give us the solution on how to compute for the value of a. And by using the, what you call this principle, equate coefficient of like terms, it is the same as in the so-called partial fraction under integral calculus. Equate coefficient of like terms for to solve for the unknowns. For e to the 2x, there is an e to the 2x on the left, and there is an e to the 2x on the left. So the meaning of this, e to the 2x on the left, the coefficient is actually 8a. And on the right, the coefficient is actually 3. So this should be equal to 3. That's why I place it here, equate coefficient of like terms. For e to the 2x, okay, the coefficient is 8a, the right hand side will be 3. So dividing both sides by 8, okay, this cancels. So a now will be 3/8. Okay. So we now know the general solution. No, particular solution. We'll just go back to this, okay? And since a is 3/8, the particular solution now will be 3/8 times e raised to the 2x. So the total general solution now, total general solution will be the complementary solution plus the particular solution. So it is k1 cosine of 2x plus k2 sine of 2x plus 3h e to the 2x. That is our total general solution. So the meaning of this, if we try to take the second derivative of this, supposed to be what will come out will be the given problem. Okay, let's try to check. Take the derivative of the total general solution. Y prime will be negative 2k1 sine of 2x. Okay. K1, the derivative of cosine is minus 2 sine of 2x times the derivative of the angle, which is 2. Okay, so it will now become negative. So 2 times k1 will be negative 2k1 sine of 2x. That's the derivative of this one. Okay. The derivative of the second one, it will be k2. And the derivative of sine is actually plus cosine. Okay. But the derivative of the angle is actually 2. 2 times 1 or 2. So 2 times k2 will be 2k2 cosine of 2x. So the derivative of this one will be this one. Okay? It is a plus because the derivative of sine is plus cosine. And the derivative of cosine is negative sine. That's why this is negative. Plus The third part is actually a constant times exponential function. So it should be, the coefficient is actually 3h, and the differential of e to the 2x is e to the 2x times the derivative of the exponent, which is 2. 2 times 3 is actually, yeah, it's correct. 2 times 3 is 6, right? Over 8 e to the 2x. So the derivative of this one will be this one. That's why the coefficient now will be 3h times 2, that will be 6h. Taking again the derivative of the first derivative. So y double prime will be equal to, it's the same. The derivative of sine will be plus cosine, but the total derivative of the angle is 2. So this will become negative 2q1 times 2, that will be negative 4q1 cosine of 2x. This is still negative. Okay? Because the derivative of sine is plus cosine. For the second one, this will now become negative y. Because the derivative of cosine will be negative sine. Okay? But the coefficient should be 2q2 times 2. So this will now become negative 4q2 sine of 2x. For the second, last part, it's still the same. Take this 6 over 8 times 2, it will become 12 over 8 times e to the 2x. Because the derivative of e to the 2x is actually e to the 2x times 2. So 6 over 8 times 2, that will be 12 over 8 e to the 2x. So the second derivative of this one will be this one. That's the total value of the second derivative. Then if we try to multiply the total general solution by 4, 4 times y will be 4y. Q1 cosine of 2x times 4 will be plus, this is plus. Okay? We just multiply this by 4, so it will become plus 4q1 cosine of 2x. This one, 4q2 sine of 2x. This one, if we try to multiply this by 4, 3h times 4, that will be 12 over 8. Okay, so this is 12 over 8 e to the 2x. So this is the total expansion after multiplying the total general solution by 4. Then try to add y double prime plus 4y. Y double prime plus 4y will be y double prime plus 4y equal to the right hand side. This one cancel with this because this is minus, this is plus. Similar terms, right? This is minus, this is plus. They are similar terms. They are both side. So this will cancel out. Okay? So, but the two terms are actually similar and the coefficient are similar. And 12 over 8 times 2, it will be equal to 24 over 8. 24 over 8 is actually 3. So if we try to add this one, the coefficient will be 3 times e to the 2x. It is checked. Why it is checked? If you try to compare this one with the given original problem, okay, they are similar. That is y double prime plus 4y equal to 3e to the 2x. So our total general solution is correct. Meaning, the complementary in particular are also correct. I will check my camera. Okay, that's it guys. That will be example number 2 under advanced mathematics. Okay? The right hand side is not equal to 0. Because if the right hand side is equal to 0, the solution will just be simply the complementary solution. That was the last topic under differential equation. Okay, guys, that's it. For those guys who are studying advanced mathematics, this is for you. If you like my video, please click like. If you want to subscribe to my channel, please click subscribe. Because I got long form videos on differential calculus, integral calculus, differential equation, and this is now advanced mathematics. I got long videos, okay? So this is for you guys. You will get something from it. So try to subscribe. And if you want to share it to your friends, please click share. Good morning, Los Angeles.